Now that you've read through the notes on Avogadro's number, it's time to attempt some calculations. So this example says determine the amount of moles in 5.38 times 10 to the 24 molecules of oxygen gas. So it's really important that you recognize what you're looking for. So it says determine the amount of moles. And we know that we have 5.38 times 10 to the 24th molecules. So on the slides, I had a couple equations down for you, and they were N equals big N over NA, and N equals N times NA. It's important that you know what each of these variables represents because that will not be given out on an assessment. So the little n stands for moles. N stands for number of particles, molecules, atoms. Okay, so it all represents the same letter. And then Na is our Avogadro's number. So the question is asking us to look for our amount of moles. So N equals N over Na. So we're just going to plug in our information. So we know that N is 5.38 times 10 to the 24th. And we know what Avogadro's number is, 10 times 10 to the 23rd, 6.02 times 10 to the 23rd. It's really important that when you're putting this in your calculator, you put it in brackets, or else you'll find some mistakes. And what we should find is that moles equals 8.94 moles of O2. And this part is really, really important. I can't stress it enough, stating the units and what you are looking for. So moles of blank, molecules of blank. That is very, very important. And other than that, we can move forward. Here's another question using Avogadro's number and the formulas that we looked at. So again, let's just reiterate what those formulas were. So N equals molecules over Avogadro's number, or molecules equals moles times Avogadro's number. Obviously, these are the same manipulations of one equation. It's just helpful for some of you. I know sometimes rearranging can be difficult. So this question says to determine the number of atoms. So we're looking for a number of atoms of neon in 0.25 moles of neon gas. So we're going to write our equation. We're looking for, oops, that was the wrong one. Erase that. We are looking for molecules or atoms, So N equals moles times Avogadro's number. So our moles is 0.250 times 6.02 times 10 to the 23rd. And N equals 1.51 times 10 to the 23rd atoms of neon. For those of you that are not super comfortable with your graphing calculator, you'll notice that in your answer on your calculator, it might say something like this. So it could say 1.51, and let's say that there were a lot of other decimal places. Sorry, that's a little messy. A couple more decimal places, and then it will say E23. This E23 is representing the 10 to the 23rd. So E23 is in replace of the 10 to the 23rd. You need to make sure that your answer is written as scientific notation, 10 to the 23rd or 10 to the 22nd, whatever the number is. But that E23 that you're seeing on your calculator is that scientific notation.